In this video, we are going to find a second derivative or a third derivative, as many as we want. That's called a higher derivative using implicit differentiation. This means that what we have learned to do to find one derivative, we can do it repeatedly to find higher order derivatives. So in this case, we want to find d squared y divided by dx squared, which means d dx of dy dx. Okay, that's what the notation means. It's the second derivative. Sometimes we see it written just as y second. Okay, so let's do this. Remember this example we saw in a previous video? This curve here is an ellipse, okay? So just so that you have in mind what we are doing. Now let's find the first derivative. Take d dx of both sides of the equation. So this is 0. And this is 6x plus 2y dy dx equals 0. Now, we want to find the second derivative. So we need to take one more derivative here. So d dx 6x plus 2y dy dx, and the derivative of 0 is 0 because it's a constant. So here we have 6 plus, and here comes the challenge. So this is the derivative of a product. So we need to do dy dx times the second without any derivative. So we have dy dx, so that stays as it is, plus y, and then the derivative of the derivative, which is the second derivative, then equals 0. And this is what we wanted to find. Okay, so we need to solve for this here. All right, so to do that, just notice here we have, this is the square of the derivative plus y d2y dx2. Okay, this must be equal to negative 6 divided by 2, which is negative 3. Now, one comment. These are totally different things, okay? The one on the left, dy dx squared, that's the square of the first derivative. The one on the right, d squared y dx squared, is the second derivative. Okay, so these two things are completely different. From there, we can just write the second derivative, right? This is negative 3 minus dy dx squared, and then divide by y. And that's it. Is it? Well, here, now we have y and we have dy dx, but we may think, well, what else can we do, right? But if you notice, we already found dy dx using implicit differentiation. Okay, this means we did this during the process, right? Dy dx, this is negative 6x divided by 2y, which makes negative 3x divided by y. And this I can plug here in this formula, and I will get negative 3 minus negative 3x divided by y squared divided by y. And now this I can simplify a little bit. So this is negative 3 minus 9x squared divided by y squared divided by y, the whole thing. And this is minus 3y squared minus 9x squared divided by y to the power 3. And this is the simplest we can write it. Well, if we want, we can write minus 9x squared divided by y to the power 3 minus 3 divided by y. It's arguable which of the two is simpler, but this is as simple as it gets. And in this way, we have found the two derivatives, the second derivative, sorry. Now, if we wanted to find a third derivative, we can keep going. Just keep in mind that for the third derivative, we will need to use the formula for the second derivative and so on, okay? We want to write it in terms of x and y, but we don't want any more derivatives involved.